Okay, YouTube, in this video what we're going to do is we're going to construct the parent function of the graph of y equals tangent of x. And so we've looked at the parent functions of sine and cosine, also their reciprocals, that would be cosecant and secant. Now we're going to take a look at tangent and its basic characteristics. And what our goal is going to be is to basically identify how we could use the framing method in order to graph a tangent function as well after we've looked at the basic shape of this graph. So let's go ahead and take a look at this basic shape of this graph. You notice that I have my unit circle here. We notice that on the unit circle our x values, our cosine values, our sine values, our y values. So when we talk about tangent, the very first thing I want to do here is I basically want to point out that when we talk about a tangent, what we're doing is we're taking our sine values divided by our cosine values, because really it's defined as being y over x. So that being said, we're already going to see a situation where our tangent function is going to be undefined wherever cosine is equal to 0. We could really easily find some angles here where cosine is equal to 0, like pi halves. At pi halves, we're going to have a cosine of 0, so our tangent function would be undefined. And also down at 3 pi halves, we have a cosine value of 0 here also. So we're going to see that 3 pi halves and pi halves, we're going to see a tangent function that is undefined. So what I'm going to do is I'm going to recommend that we construct a table here. And so what we'll do is we'll actually start our table. Let's do this. Let's do this. We'll say x is our angle, y is our tangent value. We'll start with an angle of 0. And what I want to do is I want to go by pi force increments. So 0 will go by pi force increments. So this would be pi force. And then another 45 here. So 2 pi force would be pi halves. Would be up at pi halves. If we go another pi fourth here, this would be 3 pi force. And then what we're going to do is we'll just head over to 4 pi fourth, which is pi. So this would take us 0 pi force, pi halves, 3 pi force, and 4 pi force here, which is pi. We're just going to continue this table here. So we'd have 5 pi force, 6 pi force, which is 3 pi halves, 7 pi force, which is like a 315-degree angle here, and then all the way around would be 8 pi halves. And so we're going to go all the way around this unit circle, and what I want to do is look at the patterns that show up here with our tangent function here. And I suppose I could just write 2 pi there instead of 8 pi halves. So that being said, let's go ahead and take a look at our tangent at 0. So the tangent at 0, what we're going to see here is that we get y over x, and so in other words, we get 0 over 1, or that our tangent value at 0 is just really 0. As we head to pi force now, taking a look at this, we'd say pi force, we're going to take our y value divided by our x value. And the sheer fact that our y and x values are the same here means that when we take our root 2 over 2 and divide it by root 2 over 2, we get a tangent value of 1. So of course, we know that the tangent of any 45-degree reference angle comes out to be a 1 or a negative 1 there. So we say pi halves, our tangent value here, we recognize that 1 divided by 0 is going to be undefined. We'll go ahead and write that down here, undefined. Then we'll take a look at 3 pi fourths. Now the interesting thing with 3 pi fourths is that we're over here at a reference angle of a 45, which means we'll still get 1. It's just that when we take our y divided by our x here, we're going to take a positive root 2 over 2 divided by a negative root 2 over 2, meaning that we get a negative 1. So negative 1, we'll head over to pi radians. Pi radians, when we take 0 divided by negative 1, we get 0. At 5 pi fourths, so now down here at 5 pi fourths, we would say that our y value divided by our x value, interesting, a negative root 2 over 2 divided by a negative root 2 over 2 would be a positive 1. Now at 3 pi halves down here, again, we're going to have negative 1 over 0 when we take our tangent value. So this is also undefined. And then we say 7 pi fourths. 7 pi fourths would be down here now. We're going to take y divided by x. And we notice that we take something divided by itself, but we have a negative divided by a positive, so negative 1. And then 2 pi, when we get back to 2 pi, we end up with 0 here. So let's recall a few things here. When it comes to a tangent function, or just any function in general, we talk about the period of the function being the amount of horizontal distance you would have to go from a point on the graph before it starts to repeat itself again. And so what I basically want to point out here is that we see this pattern here where our tangent function is going 0, 1, undefined, negative 1, 0, 1, undefined, negative 1, 0, and it'll be 1 and undefined. But what we're seeing here is this. Our graph goes from being undefined back to being undefined between pi halves and 3 pi halves. And so this distance here, this 3 pi halves minus pi halves, what this is going to do, it's going to indicate that the period of tangent is not 2 pi, but it's going to indicate that the period of our tangent curve is actually pi. So when we construct this here, it'll look like this. Here we'll get our x and y axes in. What we're going to see is a situation where we have going up to 1 and down to negative 1 here. We'll put these on because these are some y values that we see reflected here, and then also a height of 0. But we're going to have asymptotes wherever we are at, say, pi halves here, or 3 pi halves, or wherever our cosine value really is 0. So putting this on, we say, okay, I've got 0, pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths, so there's pi. And then 5 pi 4, 6 pi 4, 7 pi 4, 8 pi 4, so here's 2 pi. So putting on our asymptotes first, we know that at pi halves, we have this imaginary line that runs through this pi halves here. We say this is x equals pi halves. That basically indicates that this is an x value at which our function is undefined. So our graph will not cross that x value, and also at 3 pi halves. So 3 pi halves, let's see, this is half of a pi here. So if we go, let's see, pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths, 5 pi fourths, 6 pi fourths, this would be our 3 pi halves right here. And so we would have an asymptote here as well. So to put the rest of this graph together, essentially what we're going to see here is this. At 0, we were at a height of 0. I'll use a red marker here. So we height of 0. At pi fourths, we're at a height of 1. And then at pi halves, we're undefined. Now when we get to 3 pi fourths, we're at a height of negative 1 again. When we get to pi, we're at a height of 0 again. When we get to 5 pi fourths, which is the next stop, we're at a height of positive 1 again. And then at 3 pi halves, again, we're undefined. And then lastly, we say at 7 pi fourths, we see over here we're at a height of negative 1. At 2 pi, we're at a height of 0. And so what we get is this partial graph of our tangent function here. I'm going to draw it in. But basically, we get a situation where we get this always increasing curve here that stays between our asymptotes. And so if we were to actually go and I suppose construct a tangent graph here. I just want everybody to see this. Tangent. I don't know why my mouse is being all crazy. Let's try this up here. Well, maybe I'm not going to be able to do this. So I suppose, you know why. It's because I left my pencil on my stylus on my tablet there. Let's try this again. If we go to Desmos, and we type in y equals the tangent of x. Basically, what we're going to want to indicate here, let's pop this over to projector mode, is that we get this graph, and we can zoom out here, where we have just this repetitive motion again and again and again of all of these ever increasing kind of like, I guess you call these tan lines, okay? So when we look at this graph here, basically what I want to point out is that we only need to know how one of these cycles behaves. And so this one cycle that we're going to choose here is actually going to be between negative pi halves and pi halves. And so what we're going to see here is that at negative pi halves, again, if we were to go down negative pi halves here, our tangent value would be undefined. And if we were to go, say, negative pi fourths right here, we would get a y value of negative 1 when we find our tangent value here. We had y over x, our tangent value would be negative 1. So here's this. But basically, we are going to memorize this middle portion of this graph between negative pi halves and pi halves. And so to look at what we have here, you can see this up here. We see that the graph of y equals a tangent bx minus c plus d. The first thing we want to indicate is that it has no amplitude. The reason why is because there's no max and there's no min. And so if there is no maximum and minimum value, then we can say that if the amplitude is half of the distance between the max and the min, then this graph absolutely has no amplitude because it has no max and no min to take the half of the distance between. So we're going to say that there is no amplitude on this graph. Now, one thing I want to indicate here is that this a value is still going to determine the height of our frame. So let's talk about where our frame exists within this picture up here. What I want to do is I want to indicate that our starting point here is at 0, 0, and that the middle of our frame is actually the starting point for our tangent graph. And so what we're going to see here is this. The height of our frame, a, the absolute value of a, still determines the height. So we're going to see that our frame here has the absolute value of a as a height in both directions. We have the absolute value of a. You can see that that's the height of our frame here. Okay. So now this frame, in terms of the length, we say, what is the length of this frame here? We're going to say the length of this is the period, and in our particular instance here, the period of the tangent graph is always just pi. It's not 2 pi, it's just pi. So what we see here is a situation where we have an x value, negative pi halves, and positive pi halves. This would be a positive pi halves right here. But when we split up our frames, remember we split up our frame by taking this overall rectangle. We split our midline, and then we split this frame in half, and then we split those halves in half. And so what we really get is a situation like this right here, where what we're going to see is essentially this. And I'll go ahead and create a new sketch here off on the side. But our tangent graph, our parent function is going to have an asymptote at negative pi halves and at positive pi halves. And the a value there being 1 on our parent function means it's going to go above 1 and below 1. But with our frame running here, okay, we're going to say that our height of our frame is that absolute value of the a value. Again, we say here's the absolute value of a. and that the length of this is the period. We say the period is equal to pi. So the thing here that's different about this particular graph is that our starting point of our frame is still at c over b comma d. And really we should just list that up here. We would say that c over b comma d is our starting point. We get c over b comma d. This is the same thing we use with our sine and cosine curves. But basically I want you to note that the starting point is in the middle of our frame. And so with our tangent graph, with our starting point being in the middle of the frame, what that means is we're going to have to go half of the period to the right and half of the period to the left of this starting point. So if the period is represented by p, we say p over 2 to the right and p over 2 to the left. That's going to be how far we go left and right at this point. But in terms of splitting this up, we still split it down the midline, and we still split it in half and split the halves in half. And so we have these key points here. So with respect to our basic shape of what our tangent curve looks like inside of its frame, let's take a look at what it looks like. What I want you to notice is that right in the middle of the frame, and this is always true, but right at the starting point of our tangent graph, we're going to have a 0. So in the middle of our frame, we're going to see that we have this. There must be a 0 in middle of the frame. Okay. So with respect to what the rest of our graph look like, when you look up here and we say splitting our frame up, what I want you to notice is that with an a value of 1 here on our tangent curve, basically our frame went up 1 and down 1, but when you look at what our key points are in this frame, every graph has 5 key points. We just learned that right in the middle of the frame we have a 0. The other 2 key points are going to be at these parts of our frame here. So we notice that we have this graph that's ever increasing, and you'll notice that it goes through a height of -1 here and a height of +1 here. So with respect to our frame and tangent functions, you're going to see that this frame here, right there and right there, are going to have 2 of our key points. So in the middle of our frame we have a 0, and at these 2 key points here we have down here at -1 and here at +1, and it'll change depending upon the value of a. So what's on the outside of our frame? The interesting thing is that our asymptotes always lie on the outside of our frame with respect to our tangent curve here. And so what we're going to see is a situation where every tangent curve has asymptotes on the outside. So where do the vertical asymptotes lie? They lie on the outside of the frame. So what I want to do here is essentially this. I want to construct a frame that would accommodate a tangent curve if, say, our function is y equals 2 tan x plus 3. And so what I've done here is I've kind of outlined, now that we know kind of the basic shape of our graph here and how it looks through our frame, I suppose I should go ahead and finish by coloring in what our tangent curve looks like here. But we get this one cycle of our curve is this curve that approaches the asymptotes on the left or right, but is always increasing through this frame here. And so let's go ahead and take a look at this. Outlining this process here, basically what we want to do is we want to start by finding the starting point here, and then constructing our frame using the period and the amplitude. Even though it doesn't have amplitude, we're still going to use this a value to help us determine this. So let's start with this. The starting point is going to be at c over b comma d. Our amplitude, which doesn't exist, amplitude, we're going to write this here, it has no amplitude. But we still want the absolute value of a, so we're going to find that here. And then the period of our graph. So starting with the starting point here, we're going to say our starting point would be at c over b comma d. Now I recognize that in our function here we have no c value that's inside here with our x value being added on or subtracted off. So that means the value of c is 0. Now our b value here, it looks like our b value, the coefficient of x is just 1. So we have 0 over 1 comma d, and our d value is 3. So what this means is our frame is going to start at the point 0 comma 3. So let me go ahead and kind of move out of the way here so we can accommodate this here. We're saying that we recognize that our tangent function here is actually going to start at the point 0 comma 3. So going up to 0, 3, 0, 1, 2, 3, here is our starting point right here, and I'm going to indicate that that's at a height of 3. So now with our frame here, the next stop is going to be this. Constructing the frame, we're going to find from our starting point the absolute value of a. In this case, our a value looks like is 2. So we get the absolute value of a is the absolute value of 2 is 2. And I'm going to put a box around this. Even though this is not the amplitude, what this is going to do is it's going to tell us from our starting point we're going to go 2 above and 2 below this. So if I'm currently at a height of 0, 3, I suppose that means that we're going to go up to a maximum height of 5 here and a minimum height of 1 when we construct our frame. So our frame runs through this here, and I know it's hard to see, but I just went 2 above and 2 below our starting point. Now, with respect to the period, remember that we're going to go half of the period to the right of the starting point and half of the period to the left of the starting point, since our starting point with tangent, and only tangent, is in the middle of the frame. So what we're going to do is we're going to find the period, and remember that what we're going to do now is we're actually going to take that period pi and divide by b. So where it used to be 2 pi over b, we're saying that the original period of tangent is just pi. So when we take pi divided by b in this case, our b value, looks like our b value is 1, looks like the period of this graph is just pi. So with respect to constructing this frame, what we're going to do is we're going to go out half of that pi to the right and half of that pi to the left. So what I'll do here is I suppose that I'll call this pi halves. We'll call this negative pi halves. And so with what we have here, we can say, well, we can construct our frame. We'll go out pi halves to the left and to the right of this. So now our frame actually passes through now in reality, okay? Starting at the starting point, we went up and down by 2 each way, and then we went pi halves in each direction because the total length of the period here we were able to find out is pi. So with what we got here, what we're going to do is we're going to say we've got our middle line that goes through the starting point, and what we're going to do is we're going to say, oh, cut it in half. So we've got this halfway point always going through the starting point here. We're also going to cut our halves in half. So this would mean that this is the x value negative pi fourths, and we have a x value here of pi fourths. So to construct the rest of our graph, now that we've got the frame, let's just go ahead and put in the basic shape of our graph. So I want to start with this. Our asymptotes on a tangent curve are always going to lie on the outside. Why don't I switch over to a green light color here? So our asymptotes lie here and here. So with respect to the rest of our curve, a tangent graph always goes through its starting point, interestingly enough. So now the last thing we want to ask is, kind of, is A negative? And the A being negative or positive basically means, are we going to have a reflected graph or not? So because our A value is positive here, we have a non-reflected tangent graph. And since tangent is always increasing, what that means is then our graph has to kind of go up and through this point here. So our 5 critical values, here's where they are. Our first one is the first asymptote. Our second one is the last asymptote. Our third critical value is this middle point here. And then our fourth and fifth are going to be at the edges of our frames. And because we know we don't have a reflected graph, then that must mean that we're at the bottom of our frame here and the top of our frame here. And so our tangent curve, you can see how that A value still causes our graph to kind of be stretched by a factor of 2 here. So this will be a little bit skinnier than our parent function of the tangent graph that went to a height of 1 and a height of negative 1 here. This one went to a height of 2 above and 2 below, I guess, the original starting point. So here's our tangent curve. So to, I guess, graph another cycle of this, we know that we go out pi units here in terms of the period. If you were to add another pi onto this here, we would have pi halves is this x value here plus pi, which is pi halves plus 2 pi halves. And we would say that this point right here is 3 pi halves. And you could see how we could really just tack on another frame here, split it down its midline, split it in half, split the halves in half, and say that, look, the starting point's here. It must increase through these points here, and that there's another asymptote here. And so another cycle of our graph would just look like this right here. Okay. So with respect to our tangent graph, we still find the starting point, the absolute value of A, and the period using pi over B. But when we start our frame, we start our tangent curve with the starting point being the middle of the frame.